All right, it's been a long day, so bear with me here. But we're starting our new unit on parabolas. So this is unit 11, and this is the first lesson on unit 11. So you guys worked with parabolas a lot last year. I've talked with your previous teachers, and you did this for like the majority of last year, at least like a third of last year you were working with parabolas. So parabolas are U-shaped graphs. And the ones you worked with a lot last year were the ones that were y equals x squared. And of course, there were different things with this, like it could have been x squared minus 4, or x squared plus 5, or you were just like moving them around and shifting them. So now we're going to be graphing parabolas, but we're going to be graphing all different kinds of parabolas. So we're going to be graphing them up and upside down and the right way, or upwards, whatever, you know. And then to the sides also, so they open to the right and they open to the left. Okay, so the mathematical definition of a parabola. So a parabola is the set of all points in a plane that are the same distance from a fixed line, which is this line right here, and a fixed point not on that line, which is that point right there. And we'll get to what those are actually called, but this fixed line, this parabola never crosses that line, and it never actually touches that point. That point just tells you which way this is going to open. So if this point was down here and that line would have been up there, this would have opened downwards, okay? So here's some keywords we need to know. A line of symmetry where either side of the axis looks like the mirror image of each other. So this right here is that line of symmetry, and that's called the axis of symmetry. Okay, and I'm just going to label this right here. So if we look at this, I could fold this paper over and that graph would go right on top of each other. So this is the axis of symmetry right there. Okay. So the point where the parabola crosses its axis of symmetry, that's called the vertex. You guys should have used that word last year. So this right here, that's where it crosses that axis of symmetry. This is the vertex. Okay. Then a fixed line that is used to define the parabola. So this is the fixed line that we were talking about up here. And this line is perpendicular to the axis of symmetry. So that is this line right here, and it's called the directrix. This is a new word. I don't think you've ever used this word. So this is the directrix. So the directrix is always on the other side of the parabola. So it never, ever touches the parabola. Okay. And then a fixed point on the interior of the parabola that is the same distance from the fixed line and every point in the parabola. So this point is the same distance from every point in this parabola. Okay, and that point is called the focus. I already used that color. This is the focus. So this right here is the focus. Oh, and I forgot to label this. This is the directrix. And when it says that it's the same distance from every point, that means like when we go this way, like these 2 points are the same distance from that focus. These two, as I continue up, they're all the same from that focus. If like this is a +4 and this was a -4, that would be the same distance from that focus. That's what it means, okay? And then the directed distance between the vertex and the focus of the parabola, that is the focal length. Focal length. And we're going to call that focal length P. So that's our P value, and P we're going to use a ton. So this distance right here is P. The distance from the focus to the vertex, that's P. Okay? And then if I go straight out right here, so straight out to this point right there, I can draw a line right there. This point is 2P. So that distance right there is 2P. So whatever this P value is, to get what this point is, so to get what that point right there is, you double your P value. And it's the same if I go out this way. That's 2p right there. Okay, so that was a lot of just definitions right there. So we're going to be using two different kinds. We're going to be working with y equals and x equals. The biggest difference between y equals and x equals is y equals is the vertical parabolas. So y equals is up and down. So these are y equals, and it's up and down. If it's positive, it's up. If it's negative, it's down. Okay? And then there's two different forms here. There's standard form and there's vertex form. We're going to be working mostly with vertex form. So we need to get these graphs in y equals blah, blah, blah. Okay? We'll go more through this. This is more to just like go back and reference. And then also, we are working with horizontal parabolas, which these are x equals. And these are right and left. So the positive is when it's right. The negative, oh, you can't see that. The negative is left. Okay? So let's do an example right here. I'll zoom in a little bit. Okay, so we're given this equation right here, and we need to put it in vertex form. Remember, vertex form, this is a y because it has the x squared. So this is, we have to get it so y equals something. So in order to get this to be y equals, I have to divide both sides by 4. So I can just write this down here. I'll write it right here. So this will be 4y equals x squared. To get that y by itself, I just divide by 4. So that's y equals 1/4 x squared. So my vertex form is y equals 1/4 x squared. Okay, I really am just solving that for whatever variable does not have a squared. So this is solved for y. The direction of this is a y equation, and it's positive. So this is y, and it's positive, which means it's going to be up. It's going to be opening up. So I'll put opens up. Okay. Then the vertex here, all the ones we're going to be working with today, the vertex is at 0, 0. We don't have any pluses or minuses in there, so the vertex stays at 0, 0. Now the focus, we need our p-value to find the focus. And if we look at this equation right here, our vertex form equation is y equals 1/4p x squared. So I'm going to use that to find my p-value. So I need to figure, this is my equation I have, and I need to figure out what p is right here. So I'm just going to set this piece equal to the number in front of here and solve for p. So this is going to be 1/4p equals 1/4. And then I just have to see, what do I have to plug in for p to get to 1/4? Another way to do this, so see how these are both ones on top? Then I can just flip both fractions. If these are the same right there, you can flip them. So this becomes 4p equals 4, so p equals 1. So then p equals 1. And we're working with y graphs, so my focus is going to be at 0, 1. This is always your y value. If this is a y graph, that's your y value. If this would have been an x equals graph, it would have been your x value right there. Okay? And then your directrix is opposite of the p value. So my directrix is still y equals, so it's y equals -1. Okay? This is the hardest part, is just finding all this stuff. And honestly, you can just come up here and you can use this a whole bunch to help you find this stuff. And once you do it over and over again, you'll start to realize, oh, that's the opposite of p, or that one's the same as p. Okay? So let's look at this. So let's graph this. So I'm going to graph my vertex first. So my vertex is here at 0, 0. Then my focus is at 0, 1. So the focus is always just a point. Then my directrix is y equals -1. And that line goes clear across here. Okay? And then this is my p length, which is 1, which means I'm going to go out it's always double your P to go out. So from the focus, you're going to go out double whatever your P value is. So I'm going to go out, if this was 1, I'm going to go out 2. This was 1, so I'm going to go out 2. Then from there, I can just graph this up and draw this out. And I made my U-shaped graph. Okay. Okay, let's do one more example. So here, we need to put it in vertex form. This is an x right there, and we have a y squared. So my vertex form is going to be x equals. And this is going to be x equals 1/12 y squared. So this is x, and it's positive, which means it opens right. If it's x and it's positive, it opens right. If it's x and it's negative, it opens left. The vertex here, there's no pluses or minuses, so that's still just 0, 0. The focus here, I need to find my focus. So how on this graph right here, it was y equals 1/4p x squared. This is going to be x equals 1/4p y squared. And then I can just set these pieces equal to each other. So I can set this piece equal to this piece. So that's going to be 1/4p equals 1/12. They're both over 1, so I can change that to 4p equals 12. So then p equals 3. I'm just going to write that down here. Now my focus. So my focus is x. If you're working with x, your focus will be on the x point. If you're working with y, it will be on the y point. So my focus is 3, 0. My directrix is the opposite of p value. So the directrix is x equals -3. Okay, now let's just graph this. So I always start with graphing my vertex. My vertex is right there. My focus is 3, 0. And then my directrix is -3. So that's just going to be right here. And then to find these points, so I always have to find that first point. This length right there is 3, which means I'm going to go out from this point double that length. So I'm going to go out 6. Then I'm going to go out double that length, so I'm going to go out 6. Then you just connect those. Okay. Let's do 3 more just short examples, okay? So we have to write equations of a parabola with the vertex. Write an equation of a parabola with vertex at the origin given the following information. So if you're given the directrix, remember the directrix is opposite of the p-value. And once you find the p-value, you can write all of these equations. So if this is the opposite of the p-value, that means p equals -1/8. Okay, and this is y equals, so we're going to have our y equals equation. So the equation is y equals 1/4p x squared. And then I'm going to plug p in for that p right there. So that's going to be y equals 1/4 times -1/8 x squared. And then 4 times -1/8 is 1/-1/2 x squared. And when you divide by a fraction, you can flip that fraction and multiply. So that's -2 x squared. So my equation for this one is y equals -2 x squared. Okay, I want to show you guys a button in the calculator that most of you know, a lot of you know it. I don't know how many of you do or don't, but there's a fraction button in the calculator that will make doing this calculation a little bit easier. So to find that button, you go alpha and then y equals and then enter. And it will pull up that fraction, and then I can put this directly into there. So I can put 1 on top, and then 4 and -1/8, and then you just push enter, and it's -2. So again, that's alpha then y equals, and enter. I'll write that right here too. So it's alpha, and then y equals, and then enter. And that's to find the fraction. Alpha y equals, enter. And that'll give you that fraction right there. And it's good, you can do it this way, and then just always double check. So I got -2. The calculator says -2, so that's right. Okay. So let's do this one. So the focus here, the focus is always the same as your p-value. So that means my p equals 1/4. And this is in the y, so I'm using the same equation still. So this is going to be y equals 1/4 times 1/4, and then x squared. 4 times 1/4 is just 1, so that's just going to be y equals x squared. And you're done. Okay. This one, so it opens down, which means it's a y equals, and it's negative because it opens down. Which if it opens up or down, it's y equals. If it opens right or left, it's x equals. And then a half unit between the vertex and the focus. This means that p equals 1/2. So again, I'm just using this same equation because we're still using y equals. None of these were x equals. You are going to have some x equals on your homework. So this is going to be y equals 1/4 times 1/2 x squared. And then 4 times 1/2 is 2, so this is y equals 1/2 x squared. And you can always go check that by using this fraction button. So if you go math, y equals, or not math, alpha, y equals, enter. So that's 1/4 times 1/2. Whoops. Oh my gosh. Delete 1/2. That equals 1/2. And you're done. I sincerely apologize for the length of this video. I did not mean to do that, but I will see you guys tomorrow, and please make sure you take the quiz, okay? And for those of you who actually watch this, a lot of these examples are actually on your homework, so you'll benefit from actually watching this. Anyways, okay, I'll see you tomorrow.